Welcome to Lab 2 Part 1 Numpy. Numpy is a Python library for numerical computation using numbers. To use Numpy, we must first import Numpy. Import Numpy as NP. To declare a matrix in Numpy, we will use numpy.array. Let's declare matrix X equal to numpy.array round brackets square brackets with elements 1, 2, 3. Let's print X out. Note that NumPy arrays look similar to Python lists, but they are not exactly the same. To express larger matrices, we can start with an outer list and then the inner list. Let's say the first row is 1, 2, 3, the second row is 4, 5, 6, and the last row is 7, 8, 9. We will use the same matrix as before for our matrix math operations. We will also declare a new matrix X equal to NumPy array with values 1, 1, 1, and a new matrix Y equal to NumPy.array with values 2, 2, 2. To take the dot product between two matrices, use NumPy.dot, then the first matrix, comma, and the second matrix. To take the cross product, use numpy.cross. To multiply a matrix with a vector, use numpy.matmul, then the matrix M, comma, the vector X. To multiply two matrices, use the same function and replace the X with a M. To multiply a scalar with a matrix, start with the scalar, let's say 4, then an asterisk, and the matrix. The same applies for a vector. To add two matrices, use the plus sign. Before taking the determinant, let's declare a new matrix M equal to numpy.array with values 1, 2 in the first row and 3, 4 in the second row. Now to take the determinant of M, use numpy.linout, det, brackets, and the matrix M, where linout stands for linear algebra. To take the inverse, use numpy.linout.inv. To take the transpose, start with the matrix dot capital T. To demonstrate the matrix access operations, we will use the following matrix. To get a row from the matrix, start with the matrix, square brackets, the row number, let's say row 1, comma, then a colon. Here we get the second row. The 1 here indicates the row at index 1, and the colon here indicates all of the elements in that row. Likewise, to get a column from the matrix, we start with M, square brackets, colon, comma, and then the column index, let's say 0. Again, the colon means all of the rows, and the 0 means the column at index 0. In order to get the element 4 at row 1, column 0, we start with M, square brackets, the row index, in this case 1, and the column index, in this case 0. We will use the same matrix M to demonstrate matrix manipulation operations. To insert a row into matrix M, start with M equal to numpy.insert, round brackets, the matrix to insert into, which is M, comma, the row index to insert into, let's say 0, comma, then the row, in this case we're using numpy.array, then two square brackets, since this is a row, then the elements. 4, 4, 4. Then we must set the axes to 0 to indicate a row insertion. Then let's go and print out M. Here you can see the newly inserted row. Now let's reset the matrix. To insert a column, start with M equal to numpy.insert, the matrix to insert into, which is M, column index, let's say 0, then the column to insert, so numpy.array, then one set of square brackets, since this is a column, and the elements 2, 2, 2. We must also set the axes equal to 1 to indicate a column insert. Here you can see the newly added column. Now to delete that newly inserted column, we will use numpy.delete, the matrix to delete from, comma, the column index to delete, and the axes equal to 1. The same applies to rows. So to delete the row at index 0, we can just switch the axes from 1 to 0. Next, we'll cover some built-in functions in NumPy. The first is pi, which is numpy.pi. Next is infinity, which is numpy.inf. Sine in NumPy is numpy.sine. And then the x value, let's say sine at 1. NumPy.cosine is numpy.cos. And then the x value, log is numpy.log. E raised to the power of 1 is numpy.exp. Factorials in NumPy is numpy.math.factorial, round brackets, and let's find the factorial of 4. Square root in NumPy is numpy.sqrt, and let's say 4. A quick way to get a list of zeros is using numpy.zeros, round brackets, and the number of zeros, let's say 3. So here we have a list of 3 zeros. To get a matrix of zeros, we use numpy.zeros, round brackets, followed by a square bracket, then the size of the matrix. So let's say a 4 by 5 matrix of zeros. Next, we will cover 2 functions to get a list of numbers between 2 values. The first is numpy.linespace, then the starting number, let's say 0, and then the stopping number, let's say 10. Here we get an array of 50 evenly spaced numbers from 0 to 10. If we wish only to get 10 numbers between 0 and 10, we can add a third input, in this case 10. By default, linespace will return 50 numbers between 0 and 10. The next function is numpy.arange. Once again, we'll use a starting number of 0 and an ending number of 10. So here we have a list of numbers from 0 to 10 with a step size of 1. And by default, this function will use a step size of 1. In order to change the step size, introduce a third input and then the step size, let's say 0.1.